Okay, so we were doing question number 24, about to find the acceleration of this system. So this is the whole system. The only thing making the system move is Fg2. So we do sum of the forces is equal to m total A, and it'll be Fg2 is equal to m1 plus m2 times A. So we're looking for A, so A will be equal to m2g over m1 plus m2. m2 was 0.5 kilograms times 9.81 meters per second squared. And then that's going to be divided by 1 kilogram plus 0.5 kilograms. A is equal to 4.905 divided by 1.5, 2.04 maybe, if I can trust my math. Oh, and it's not 1, it's 1.9. Sorry, now that I can actually see better, this is 1.9, and this is 1.9, and now it really is 2.04 meters per second squared. Okay, that's part A. Actually, that's part B. Part A wants the tension. So to look at the tension, you got to either look at M1 or M2. It makes absolutely no difference which one you look at. If you look at M2, there'll be Fg2 pulling down and Ft pulling up. Do sum of the forces is equal to M2A. Down is positive, so it'll be Fg2 minus Ft is equal to M2A. And so you're looking for Ft, so take this over, bring this over. M2g minus M2a equals Ft. So Ft will equal M2 was 0.5 times 9.81 meters per second squared minus, oh, this one's A, it just looks like a G, minus 0.5 times the 2.04 you just found. And when you do this, you get an Ft to be, I think it's 3.88. Yeah, 3.88 newtons. Now you could have also done it on M1, and in this case it's easier. Whenever there's friction, it's always easier to do it on the one hanging down, but because there was no friction, if you had done it on M1, the only force that would have been acting on M1 was the Ft. And so when you did sum of the forces is equal to M1A, it just would have been Ft is equal to M1A. So you could have just done 1.9 kilograms times the 2.04, and you'd get to 3.88 again. Okay? So that's number 24. Number 25 is a similar setup. Number 25, it says an air track, and an air track is like an air hockey table. So the object on the air track is going to be floating on a layer of air, which means it's frictionless again. Okay? So it tells us it's on an air track. Sorry, you just have to move it so I can see the question. 40 kilogram slider connected to a 25 kilogram mass hanging over the edge. Okay, and it wants to know how long it's going to take, which means after we find the A, we will have to do kinematics. Okay, so Fg1, again, isn't going to affect the motion. The only thing that's going to affect the motion is M2. So M1 is 40 kilograms. M2 is 25 kilograms. And so if we look at the system, once again, the only thing moving it is going to be Fg2, because Fg1 and the normal on 1 are just going to cancel each other out. So if we do the sum of the forces is equal to M total A, it'll be Fg2 is equal to M1 plus M2 times A. And again, we're looking for A. So M2G over M1 plus M2. Now, because we're going to have a mass on the top and the bottom, we don't actually have to change to kilograms. We can leave it in grams. So 25 grams times 9.81 meters per second squared over 40 grams plus 25 grams. Now you can change if you want. You can divide the 25 on the top by 1,000 to get kilograms, and you can divide the 65 on the bottom by 1,000 to get kilograms, but they're just going to cancel in the end, so you don't need to do that. All right, so we do the math, and we should get 3.77 meters per second squared for A. So then the question wants to know, if it starts from rest, how long will it take? How long will it take to travel 0.85 meters? Okay, so it's giving us V, or delta D. It's giving us VI, starting from rest is 0. 1/2 A delta T squared, and we're rearranging for T squared. So multiply by 2, divide by A. So 2 times 0.85 meters divided by 3.77 meters per second squared. Don't forget to take the square root, and you get 0.671 seconds. If you get 0.45 something, you've forgotten to take the square root. Alright, so there's your homework. I'd like to do a couple of new examples with you that are just a little bit more complicated, because these two both didn't have friction in them, and that's kind of sad. So let's do one example with friction, sitting on a level surface, and then we'll go to an incline. Okay. So example 1. Here's block 1, still connected to pulley, hanging over an edge is block 2. Let's make mass 1, let's see, 10 kilograms, and mass 2, 20 kilograms. Okay, and let's say the coefficient of friction is 0.3. Alright, so FG2 is pulling down, F friction is pulling back, and that's the friction just on number 1. It's the only one sitting on the surface. FG1 is going this way, Fn is going this way. So this time when we draw our system out, FG2 is going to pull this way, and friction is going to pull backward. Okay? And FG1 this time becomes important only in the sense of finding the Fn1 for friction. Obviously, the system is going to move in the direction of Fg2. Friction will never stop it from, or never make it move. It'll just try to prevent it from moving. So if you want, you could start by finding Fn, but hopefully you know Fn on 1 is just going to equal Fg1 because it's on a level surface. Okay? And so then we will do, on the whole system, sum of the forces will equal M total A. And so it'll be Fg2 minus friction will equal M1 plus M2 times A. And we're wanting to find A. So A will equal M2G minus mu Fn1 divided by M1 plus M2. So A will equal M2G minus mu M1G over M1 plus M2. And so now fill in your numbers. M2 was 10 kilograms times 9.81 meters per second squared minus 0.3 times 20 kilograms times 9.81 meters per second squared divided by 20 kilograms plus 10 kilograms. First term is going to be 98.1. Second term, that's going to be like 6 times 9.81, so really ends up being 4 times 9.81. And then take away, divide by 30, 1.308, I think, meters per second squared.